today we have with us Manuel Chakravarty. I'm saying that right?
Yeah, perfect.
Yeah, Manuel, awesome that you're here, and
thank you.
Yeah, we'd love to hear a little bit about your view. You've of course been working with IOHK, now IOG, for a while, and maybe for the viewers we can just have a little general introduction about who you are and how you found Cardano, and yeah, we'll take it from there.
Okay, great. Yeah, thanks very much for having me. It's really great to be here.
Yeah.
And yeah, I'm a computer scientist. My background is very much in programming languages, compilers, high performance, and distributed computing. And I've been working on Cardano for more than 4 years now. And beginning together with Philip Wadler from the University of Edinburgh, building up the Bluetooth team. At the time, I was leading the Bluetooth-related research together with Phil, and also responsible for architecture and the engineering team.
Yeah.
And yeah, that's when we invented the extended UTXO model. We did Bluetooth Core. We designed the Cardano native asset technology. And yeah, and we architected and built the Haskell-based development environment for smart contracts on Cardano.
Yeah.
And
you've been busy, it sounds like.
Yeah, it was also a few years, so
yeah.
time to build some things. And yeah, at some point, Michael Peyton-Jones took over the lead of the engineering team, so the engineering lead.
Yeah.
And I joined the Hydra research team and been involved in the creation of the Hydra head protocol.
Oh, right, okay.
And yeah, these days I'm part of research and most projects, I guess, that have something to do with Bluetooth or layer 2 technology. Yeah, I'm involved in a lot of these projects in one way or another.
And when was the first time that you heard of Cardano?
Well, it was really it was Phil who asked. Phil Wadler, he's a professor at the University of Edinburgh, and he has a adjunct position in the blockchain lab at Edinburgh, which is run by Aggelos Kiaias, who is the chief scientist of IO. And yeah, he basically asked whether I would be interested together with him to have a look at how can we do these smart contracts for Cardano. And before that, I mean, I did some playing around with Ethereum and so on, so I knew about smart contracts. But that was really the first real contact with Cardano.
Okay. Okay. Yeah, fascinating. To hear a little story, the bridge. Philip Wadler has brought more to the table than just his brain then, but also of others. And Haskell, like so there's many programming languages, of course. And where did you and Haskell meet? I mean, that's one of the core languages and underpinnings of Cardano as well. Functional programming. How did you two get introduced?
So actually also partly Phil Wadler's fault.
Okay.
When I was a computer science student at the University of Karlsruhe in Germany, I came across a book called Introduction to Functional Programming, written by Richard Bird and Philip Wadler.
You wanted some light reading, right?
Well, it was in the university library, so the kind of stuff you find in a place like that. And unfortunately, Richard Bird passed away recently, but he was in Oxford for a long time. And I believe the book was based on one of the introductory computing courses at Oxford.
Okay.
And they describe the way to calculate with programs. And what I mean by this is in mathematics, if, for example, you've got a function, you can, there are certain rules how to compute the derivative or how to integrate a function.
Mathematical functions, right?
Right.
Yeah.
And so this you can regard as calculating with functions, because you've got a function and you compute the derivative, which is a new function, right? So you have like an algorithm to take one function to another function. And in that book, one of the really cool things in that book I found at the time, I mean, I still think it's cool, was that they did this with programs. And actually, this goes back to something called the Mertens formalism, BMF, which was introduced by Richard Bird and Lambert Mertens. And Lambert Mertens is actually a Dutch computer scientist who, I think at the time, he was at the Mathematisch Instituut here in Amsterdam.
Okay.
And
Amsterdam
this is
made a more market one.
yeah, it's now it's the CWI. So that was the predecessor institution. And
Pre-CBI, sorry?
CWI.
CVI.
Yeah, the Centrum für Wiskunde.
Okay. Right.
And yeah, so Lambert and Mertens, they developed this way of calculating with functional programs.
Right.
And in fact, I mean, this has really been very much a British-Dutch collaborative exercise. So there were a few universities in the UK, Oxford, people at Imperial College, later also at Glasgow University. So people in the UK, but then in the Netherlands was Mathematisch Instituut, so Lamberts, but also people in Eindhoven and Nijmegen, also Utrecht, who really were interested in this kind of calculating with programs, like using programs as an object which you can manipulate, like a mathematical object. And in order to understand the semantics, what does it mean, a program? Yeah. And how do you can you reason about programs? That's what I tried to figure out.
Okay.
And that was really in that book. And I've been busy with computers and math in my youth. And so kind of this idea that you can calculate with programs was kind of like, wow. So that and this is really in this book actually wasn't Haskell. But I forgot the name of this language. It was kind of their own Oxford University language, but which was similar to Haskell. Okay. The later edition of the book actually was then also in Haskell. But this was really the style which inspired and founded the type of programming languages that Haskell is. Yeah.
An amazing sequence of events after picking up this book that you did in the library, and I didn't know that the Netherlands has such a hugely strong base.
I think one problem, so two problems. The group in Nijmegen, they designed their own programming language called Clean, and which is very similar to Haskell. But because Haskell was this like open source project spread across lots of different universities, and Clean was really mainly Nijmegen product. They did a lot of great stuff, but in terms of user base, I mean, the open source project just outran them at some point. And then the PR, the Dutch PR just wasn't good enough. The tech, great, but in the UK, they're just better at selling things. I don't know.
I can imagine, especially if
a lot of people don't know this. It's really like one of the core technologies underpinning Cardano is going back on foundational research in semantics of programming languages in the Netherlands.
Okay.
But that's
Yeah.
rarely known fact.
Well, we're going to make it slightly more known then. Yeah, well, that's a great introduction about, you know, yourself and your worlds of Cardano and yours coming together. And then, you know, we'd already spoken before, and I was thinking, okay, what are nice questions that I think the community would be interested in, that I'm interested in, and also would be something that you have an insight in. And yeah, we basically split it into 3 categories, and I have some questions amongst for each of them. And the first is, you know, the Cardano scientific approach, you know,
right.
Of IOG, formerly IOHK, and that's something that a lot of the Cardano community really stands on as a principle that it finds very important. And I think it's great to have you, one of the researchers, to also express what your ideas are about it, what it means from a more practical sense. Secondly is scaling EU to XO. Well, you already mentioned Hydra is one of your brain children then, and that's something that I think many people are also interested in the whole community. Yeah. And lastly, you know, NFTs, I think, are in a situation where they're getting a bit of a bad rap for people, especially outside of the crypto industry. They see it as a quick, you know, slapping a picture onto an NFT and trying to sell it for a lot because you're making the next Van Gogh or Van Gogh, I mean. Yeah. But I think it would be interesting also to chat about what are NFTs from a technical sense, you know, because I've already seen some interesting white papers where they are really using the function from an NFT from a technical perspective, which I think is very interesting. And that's something that we can dive into a little bit more.
Sounds great. So
likely we're going to also split this part into a couple of videos.
Yeah.
So starting with the first, Cardano's scientific approach of IOG, I take it then, right? IOG is the one that really built Cardano to start with.
Right, exactly.
So it is IOG's scientific approach. And this is something that Charles Hoskinson also especially likes to mention. Firstly, there was what we already talked about a little bit before, was the definition, right, of the what is the scientific approach versus formal methods, because that often gets confused. Maybe we can start with some definitions. Would you mind?
Absolutely,
giving your view on that?
So I mean, I don't know how widely people realize this, but IOG is really special in that the very sizable research department is really, I mean, this is like a high-end university research department equivalent. And there are few companies on this planet which have a comparable research capability, and certainly none in that size. I mean, huge firms like Google or so, of course, they also employ a lot of very good researchers, but anything at the scale of IOG, I think it's probably unique.
For its field.
Generally, I mean, that for a company, an institution who also has to be economically viable and isn't per definition like a university funded by through a government, to have a research department of that size and with that output at absolutely leading top conferences, I wouldn't know any other firm who's got this capability, whether in computer security, cryptography, or anything else.
Okay, wow.
Yeah. But this is really essential in our domain, because in modern cryptography, it's basically there are 2 ground rules in order to be able to create something which is secure. Number 1, you need mathematical analysis, which means you need academics who can reason about what you're doing in a mathematical way. And it needs to be open. This is really, if you look at how cryptographic protocols, I mean, it's not just blockchains, but the encryption we are using in our web browser, how these things are created, these are the two ground rules. And it's really, of course, Charles's and also, of course, Arkelos's insight and from the start point of view that in order to really create the next generation blockchain, we need this type of research and we need this foundational approach to cryptography because blockchains as a technical device and all the cryptography around them are too new. And there are so many things we don't know yet.
Yeah.
And with we, I mean the joint research knowledge of the planet. And so in order to create something like that, we need to do this foundational research. And we need to not just write some white papers and kind of it's gonna work somehow approach, but we really need to do it the same way that modern cryptography is being practiced, namely mathematical analysis and everything in the open. Right. No secrets. And this is really the basis. Now, coming back to your point about science and formal methods, science, I mean, is really about the research, developing new cryptographic protocols, developing new research in programming languages, in all kinds of areas. I mean, there also economic research is important for blockchains. We have to talk about incentives. So this brings in game theory. So it's actually quite broad. Yeah. And we need innovation in all of these areas. But then that scientific output is usually a research paper. It's a peer-reviewed research paper with often a mathematical analysis of whatever it describes, and we know it's gone through peer review, it's been published, so other smart people in the field have looked at it and they thought, yeah, it holds water. They couldn't find any immediate flaws. So that's step one. But what we need for Cardano is software somebody can download and run. So how do you get from this research paper, LaTeX, nice formulas, to being able to click in your web browser on something you can install on your computer? And this is, we do all this work, we do apply all this math to be certain about the quality of the protocols. Now, if we just would go and just implement it in some arbitrary way, and then say, yeah, this was inspired by this paper and should be good. I mean, it seems very strange to have such a foundational approach on the one hand with the research and then just implement something. So what Charles likes to call it is evidence-based development. We want to have a chain of evidence which takes us from the research to the code you can download. And this is where formal methods come in. Formal methods is basically a way to use mathematical methods, and that's all kinds of different mathematical methods, to get us from the research paper, from something theoretical, to a piece of software where we have more than usual confidence in that it correctly implements what's in this research paper. So it's the bridge, if you like. And so there are science and formal methods, they go together. And it's quite interesting because these people I mentioned in the UK and in the Netherlands who were working on calculating with programs, I mean, they were at the time, they were creating some of the foundations for what we call formal methods these days.
Okay.
Of course, formal methods is broader. This is one particular form of formal methods, and there are all kinds of formal methods. But that's basically the research area where they were operating in.
And how do I mean, everybody knows that in software development, you hear a lot about agile, right? And run and break and try and fail and start up again. If you think of the term agile, what does it mean for you in this sense of development?
So, first of all, people sometimes make it out as if there is a dichotomy between formal methods and agile development, because it sounds like formal methods is like old style traditional waterfall method, and then we have agile, and that's cool. And but I don't think that this is inherently opposed. But in order to understand how the two relate, you have to see there's different types of software. Of course, Facebook can do move fast and break things, because we are all used to that, to Facebook not working, right? I mean, you're not particularly surprised if something doesn't work. It's kind of part of the normal operation. But if you transfer these 10,000 ADA and they don't appear at the receiver's wallet, then I think you would be a bit upset. And of course, we can extend this. I mean, control systems for airplanes, right? I mean, they should work properly, right? And medical devices, which these days also include a lot of software. I mean, this stuff, breaking things for medical device means breaking humans. This is just not acceptable, right? So it depends on the application domain, how much you can break things.
Yeah.
So I think that's important to understand.
Yeah. And because I was going to say like about that from, the perception that people have of breaking things in versus formal methods, that they shouldn't be, immediately perceived as being separate worlds, that you can't have both in one. But surely there are moments where, that Cardano's approach needs to choose, let's say the more prolonged road, or perhaps, let me not answer for you, but instead, what are some of the drawbacks perhaps from the formal method, or let's say scientific approach, where you would say, keeping an agile approach, we did find it, but it took us some time to make it work. So what I'm trying to say is, or ask is, where do you see sometimes these are the drawbacks from the scientific approach, these are the advantages, these are the drawbacks from an agile approach, these are advantages, and how does Cardano find the middle way?
So in our space, the two have to go together. So there are some things where we have a specification, and that specification needs to be in the software at the end of the day. The Ouroboros consensus protocol. We can't implement something like Ouroboros. It has to be exactly Ouroboros, otherwise all the security guarantees are void. But I mean, this is a very small piece of the software on one hand. And then, so a wallet is a different piece of software. In a wallet, there are some things which have to be right, but there's also user interface. The user interface of a wallet benefits from A/B design in the same way as any other web page, right? So in that way, there's a lot of software which isn't different. So you really have to look at, there are some core components where we have very stringent guarantees, and these need to be part of the specification, and that can't change. But in both the smaller as well as the bigger, we can be very agile. In the smaller, daily development practice. And this also goes back to what does it mean to be agile in the first place. I mean, I think the agile community ask two people and they give you, and they're going to fight immediately. I've tried it. It works.
Going with your definition.
But I mean, some of the things which are standard is you have sprints in which you, of 1 or 2 weeks, where you have a bunch of issues which people are assigned to solve. And then after a sprint, you look back and what has worked and so on. I mean, these kind of processes to organize software development is actually exactly what's happening at I/O. So in that sense, there's no tension with the formal methods, science-based approach in the first place. But also in the big, I think, especially in development of Cardano, we have shown that the two can go together. So take, for example, the incentivized testnet for Shelley development. On one hand, we had a formal specification for the Shelley Cardano ledger rules, right? And we had to implement this. But on the other hand, we had this experimental setup, which was the ITN, where we could experiment and have some sort of MVP, some kind of product which could kind of let us get an idea of where we want to go without implementing everything from the get-go, which allowed us to get a lot of feedback about how do stake pool operators actually operate? How do they behave as a group? How much engagement we get from these people? I mean, these are all questions which a formal specification can't answer for you, right? And these questions need to be answered, like in the rest of software development, using these experimental techniques. And we could use these experimental techniques in the ITN and at the same time have a formal specification for the Shelley ledger rules. So in that sense, even in the large, we can make use of both approaches. It's a question of what do you use where.
Yeah.
Right.
Yeah. Okay. Yeah, great. I mean, this is...
Catalyst is another example. Catalyst...
How do you mean?
Catalyst is really...
So maybe
step
first,
by step.
Catalyst. What is Catalyst?
Catalyst is the startup to the governance infrastructure for Cardano, where the idea is that at the end of the day, the community of Cardano users, of token holders, is determining the future of the blockchain.
Right, where there's proposals that people write and then get voted on by the community, whether or not they will get the budget to execute it.
Exactly.
Yeah.
And Catalyst is in multiple rounds, increasingly bigger budget, has been starting this process. But this wasn't like fully integrated in the blockchain, but run attached to the blockchain is increasingly better integrated into, for example, Daedalus wallet and so on. So it's also something where we didn't have a full specification and then was fully implemented and then we use it, but it's incremental. And from each iteration of Catalyst founding round, we learn what works, what doesn't work, and it makes us change how we continue with the development. And in this sense, it's agile. It's do the smallest things you can do, give it to people, get feedback, react to the feedback, iterate on that, go through the next iteration and continue like this. So I think both Catalyst and ITN good examples how you can have a very agile approach at one hand, but still use the formal methods for where it matters. Because for voting protocols, we still use science, mathematical methods to make sure they're secure, they're private, and so on.
Okay, and now, maybe just to wrap up the scientific approach segment. You say that, Cardano or IOG has a very large research department and it's churning out at a rate that's equivalent to large companies. What is it working on right now? What are the research papers that the team is working on, and is there a roadmap of where the research is going?
So there's not only one research stream, there are multiple research streams. There's work in the protocol area. So Ouroboros is not just one protocol, but there are various versions of Ouroboros. I mean, even in Cardano, the implementation, we've had 3 different protocols already delivered.
Yeah.
And there are more protocols for which we've got papers, and there are more papers for more protocols coming. And maybe then you might ask, why couldn't we just design one good protocol and be done with it? But when we talk about this family of Ouroboros protocols, it's not that one is replacing the other, but successive protocols are investigating particular new interesting aspects of the protocol. For example, the Ouroboros Praos is the protocol which is live at the moment. And Ouroboros Genesis is a protocol which is in particular concerned about trustless bootstrapping of new nodes. So it's one particular aspect of having a blockchain a consensus protocol, which has been investigated by Genesis.
Trustless bootstrapping of new nodes. That is a new sentence for me.
So if a new SPO, you're running SPO, right? If a new SPO comes along and they switch on a node, how can this node convince itself, I mean, it's really about the software on the internet, that what it boots up from is really the valid blockchain? I mean, there could be entities, adversaries, trying to convince this new node of a fake chain. Like fake news, we could have a fake chain. The fake chain is a little bit different distribution of
slightly more in my wallet, slightly less in yours.
Exactly. So how do we make sure a new node doesn't fall for a fake chain? Right. And that's the question which is answered by Ouroboros Genesis.
Wow. And what a nuanced specific research as well. Yeah.
Exactly.
Okay.
Or Cryptonis. I get these Greek names.
Yeah.
Archelos is Greek. So
there's more. There's the theme of mythology in ancient Greek comes more than once in Cardano. Yeah.
Cryptonis is about privacy. How could we have a proof of stake blockchain where without knowing how much, who has got which funds, we can do staking? So how do you not give away information about your possessions by staking? So having this kind of additional level of privacy, that's answered in that paper. And so when I'm saying there are new protocols coming, doesn't mean like something completely new. It's building on the existing technology, but it's adding an aspect like that, like adding some privacy, adding bootstrapping, making the protocol more robust about things like net splits, where on the internet, nodes sometimes can't communicate with each other for a while. These are all things which are step by step addressed by these papers, and there's research in this direction. Also in the Plutus domain, we are working on better ways to write smart contracts. We've been in past papers, we've very much looked at what in computer science we call a state machine. So it's basically describing a program as a continuous set of states and rules how you get from one state to another. You can imagine in a crowdfunding contract, your initial state is you start the crowdfunding campaign, and then you're in the state of the campaign is ongoing, and at some point you reach the deadline where everybody must have paid in. Then you're in the state of I've received all the funding, or I've received funding but it's not been withdrawn yet, and then there's a certain period until which it can be withdrawn, and then you're in the contract is finished state. So you can think of smart contracts going through these states, and that's a nice way to reason about them.
Right.
But at the moment, the way you write the Plutus contracts, this is kind of implicit. Maybe this is how you think about the contract, but it's not how you write it for the deployed contracts. And this is something we want to change to make it easier to understand what a contract does.
Right.
So that's also a research direction. So there's really a variety of Then, of course, the whole Hydra layer 2 story is also ongoing.
Maybe that bridges nicely into the next